In this lecture, we're going to talk about a fundamental tool in analysis of algorithms, and it is recurrence relation. This is kind of mathematical topic but extremely useful in complexity analysis. But we will try to keep it very simple so that if you just know some basic mathematics, you will be able to understand it. So don't get scared. So what is recurrence relation? And why we are going to understand it at this point in time. Let's first know what recurrence relation is. A recurrence relation for the sequence a0, a1, a2 going all the way to an is an equation that relates an to certain of its predecessors a0, a1, a2 going all the way to an minus 1. Sounds so mathematical? Let's exemplify it. So simplest example we can take here is a factorial. Factorial of any number n we all know is fn equals to n multiplied by fn minus 1, or you can say factorial of n equals to n multiplied by factorial of n minus 1. You see here we have defined this relation of fn, or the relation of n, with its predecessor, which is n minus 1. So this is recurrence relation. Let's take another example of Fibonacci sequence. Fibonacci series is a series of numbers such that each number is sum of two preceding ones. So how do we calculate the nth Fibonacci number? Like this, fib of n is equals to fib of n minus 1 plus fib of n minus 2. That is the sum of two preceding numbers. As each number is sum of two preceding numbers in Fibonacci series, again we have to find the relation of n with its predecessors. So this is again a recurrence relation with some initial conditions f0 equals to 0 and f1 equals to 1. Or you can say fib of 0 is 0 and fib of 1 is 1. This is always true. And in case of factorial, the initial conditions are value of factorial 0 and the value of factorial 1 is 1. So clearly the recursive algorithm for calculating the nth Fibonacci number and calculating the factorial of a number n uses this relation to solve the problem. Without this relation, there is no recursion. So whenever we are going to write a recursive solution to a problem, we first need to know the recurrence relation. And the initial conditions of recurrence relations are generally the base case in the recursive algorithm. So the first important thing about the recurrence relation we just saw is that recursive algorithm is an implementation of recurrence relation. Recursion is base of many algorithm design techniques. Whenever we are able to find the recurrence relation, we can fit in the recursive part in those algorithms, as well as in pure recursive algorithm. Now, another big thing about recurrence relation is about finding out the complexities of such algorithms. Recurrence relation can also be used to know the complexity of those recursive steps used in the algorithm. For example, if we want to find out the time complexity of the algorithm to find out a factorial of a number n, you know the recurrence relation. Write the recurrence relation. Now write it in terms of time consumed, or write it in terms of t. So convert fn to tn and write tn minus 1 at the place of fn minus 1. Right. Now multiplied by n is a constant operation. So we directly write its part of complexity. Multiplication is constant time operation, so let's write 1 unit for it. So this is the recurrence relation. Tn equals to tn minus 1 plus 1 unit for multiplication. However, there is one more unit for n minus 1 subtraction that we have with tn minus 1 term. So total of 2 units along with tn minus 1 calculation. but we'll go with 1 as both 1 and 2 are constants and it is not going to make any impact. So this relation is also a recurrence relation. But it is the recurrence relation to get time complexity of getting the nth factorial. It is not the one to calculate the factorial itself. So this is the time consumed by the algorithm to find the factorial of any number n. But to get the actual value of time complexity, we need to solve this equation, and that we are going to see in next lecture.